Greenland's glaciers calls for covering only a portion of the ice sheet.
It's really just the periphery of glaciers that need to be covered. That's where the melting is taking place.
Jason's large-scale plan targets a zone called the ablation, the outer 15% of the ice cap, where the ice is melting most rapidly.
You can think of the Greenland ice sheet like a giant bowl of ice cream. It's frozen at the center, but along the edges, it's melting and dripping off.
If the blankets are laid on just this belt of ice instead of the entire Greenland ice cap, they should stop the melt using the least amount of resources. Jennifer and Kevin fly the supplies to a holding area on the ice, where they'll await instructions from Jason. He and Basil are looking for the best location to conduct the experiment.
I'm looking for the most sensitive part of the glacier, where the melt rates are very strong, where we can really put this material to the test.
These weak spots are called melt lakes. Their deep blue color is stunning, but they're deadly for glaciers around the world.
Because of the lake's dark surface, it's absorbing all of that sun's energy, acting like a magnifying glass that's focusing the energy and melting the ice below.
As more and more ice melts, the water seeps down to the bedrock. There, it acts like a lubricant to move sections of glacier towards the sea. This process is accelerating the speed these glaciers move to almost 13 kilometers per year, dumping more and more ice into the ocean more quickly. The best way to minimize the melt lakes is to preserve the ice surrounding them.
If we could cover the whole area above this lake with reflective cover, we could slow down melting in a way that could prevent this lake from filling to the point that it drains. And that could slow down this glacier's march toward the sea.
The lake should become visible in a few minutes.
I see it on the horizon, I hope. There it is, it's big.
Oh, it's big, all right.
Jason has chosen a melt lake almost 2 kilometers wide. It's being fed from all sides by rivers of glacial meltwater, and it's getting deeper by the day.
This melt lake is big, and it fits what we need. We're going to land and make sure that the surface is safe.
But the lake is far from safe. This floating ice may have risen from a widening crevasse at the bottom. The whole lake could suddenly collapse at any time.
Homem tem um coeficiente intelectual alto ou muito alto, é heterossexual, o seu aspecto físico é normal e até atraente, tem amigos e amantes, tem até esposa e filhos, é o que muitas pessoas chamariam um tipo fixe. Este homem é um assassino em série.
Assassinos em Série estreia domingo 23 de agosto às 22h10, só no Discovery.
Glaciologist Jason Box has found a melt lake, where the Discovery team can conduct an experiment to see if they can stop the Greenland ice cap from melting. But like many glacial melt lakes, this one is unstable. It could collapse while the team is working here. Such a catastrophic failure occurs when the base of a melt lake suddenly gives way. Millions of liters of water surge down into the heart of the glacier, taking everything in or near the lake with it. Since the team has to camp by the lake for the blanket test, Jason and Basil want to test the bottom for stability.
The melt lake's very dangerous because you don't know when it's gonna go. We know that these lakes drain and they do it fast. And so it's like Russian roulette on the melt lake.
What happens if the lake starts to drain?
Look, if you see any air rushing up or icebergs breaking or you hear something, we better head straight for the shore because this thing could go at any moment.
It's almost inconceivable the entire lake could vanish in a matter of minutes. But the effects of global warming can push natural systems like glaciers to sudden breaking points. Jason will deploy a free-floating probe to look for weaknesses on the lake bottom.
Here we are. We're at 35 feet. That's about as deep as we've found. This would be a good place to deploy this thing.
To predict the probability of a catastrophic collapse, the probe measures the lake's depth and how much sunlight it reflects.
And gently in the water. Good luck, little guy. Send us lots of data.
The data are transmitted to Jason's computer via satellite. But it's already obvious the lake is unstable.
Look at the water bubbling up right there. See
That's
it?
coming from the crevasse.
Bubbles rise from the bottom of the lake as it absorbs the sun's energy and melts deeper, releasing air pockets.
We're on the melt lake, and we see a rush of bubbles coming up to the surface, and it's quite wide, and I'm thinking this could be the beginning of the lake draining right beneath the boat.
Our engine just stopped.
That's not cool. Come on, man.
It's time to leave the probe to do its job and get off the lake.
Come on.
Within minutes, the probe begins to transmit information. It indicates that the lake bottom will melt deeper while the team is here, but there's a low probability it'll collapse before they deploy the blankets.
This is an ideal site for this experiment because we've got strong melt rates, and we're going to be able to really test this material and see if it works. And if it works here, it's going to work elsewhere, and then we know that we're going to be in business.
To save Greenland's ice cap, Jason would have to cover the entire melt zone with reflective blankets. That's over 250,000 square kilometers, an area bigger than the UK.
I understand that this is a radical concept of covering glaciers with reflective material, and that concept is met with skepticism. But that doesn't mean that we shouldn't give it a try. What excites me about this and what makes me feel proud is that we're among the first people to take these first steps towards tackling the negative aspects of climate change.
Jason is now ready to test the prototype ice blankets on the Greenland ice cap, just above the Arctic Circle, next to the rapidly growing melt lake. He calls in the rest of the team to begin the experiment. The heavy rolls of polypropylene have been brought here from Austria. Now the team and a small construction crew hit the ice. The camp is only 160 kilometers from civilization. But once the helicopters leave, the team may as well be on another planet.
This is a majorly hostile environment. If something went wrong, you're dead. If you fall down a crevasse, in 10 minutes you're dead. If you get sucked down a moulin while you're out on the melt lake, you're dead.
Data from Jason's probe show the lake is growing deeper by the day. The sooner the team can deploy the blanket, the better. If they can come up with an efficient way to do it, the techniques used here could be scaled up for the huge installations envisioned by Jason. Kevin O'Leary, the team's logistics expert, is watching the clock.
Nobody knows how long it's going to take to cover the glaciers with blankets. So to set ourselves a benchmark, we've decided to try and lay one of these blankets every 10 minutes.
But it takes a full day to move the rolled-up polypropylene blankets into the 2-acre drainage zone uphill from the lake.
We've planned this so that we're rolling downslope to the west and with the wind at our backs, but we're minimizing the amount of labor.
Jason hopes the reflective properties of the material will mimic those of snow. For the past 120,000 years, layers of snow compressed centimeter by centimeter to create the ice that now covers Greenland. For much of the year, the snow reflects sunlight back into space, keeping melting to a minimum. But the climate is changing in the Arctic. The snow melts earlier each season, exposing grayish glacial ice, which absorbs rather than reflects sunlight. As the ice melts, it forms rivers and lakes, which compound and accelerate the melting.